this shape right here, the top of this egg, this is an ellipse, you know? An ellipse, or it could be called a parabola. Now, you know, I'm not a mathematician, but this is a thing, this is applied geometry. And most of the ways I figure out things are mechanical ways of figuring out things. So, that looks like a part of a golden mean shape. And I can't even remember what the ratio is for that, but golden means are kind of cool. And an egg, that egg form is a very beautiful shape, okay? So I don't want to screw it up by just freehanding it, okay? So I want to find a method, a mechanical method for doing that. So one mechanical method is, and I learned this, I took a trip in some of my studies of looking at other sculptors. I went to Barcelona, Spain, to look up this guy named Antonio Gaudi, who was an architect, but his forms, he had a lot of very beautiful sculpture of forms, and one of his theories was the idea of the parabola, the parabolic arc being the strongest arc available. For strengths, for stresses, as opposed to the old school idea of just the Roman arch, which was a half circle set on columns. So he had this idea that this parabola was a much stronger arc. And I don't know if it's true or not, but most of his buildings he designed around this idea. And one of them that you can look up on, well, you can look up Antonio Gaudi on Wikipedia, or you can look up the Sagrada de Familia. So this is a parabola. This arc right here. Can you see that good against my shirt?
Yeah, it looks good.
This is a parabola, a parabolic arc. How you figure that out in theory, in geometric theory, and it's a parabola here, it's a parabola here, it's still a parabola here, and this is what Gaudi did to come up with all his arcs for his buildings. His idea that if this is the way nature, if this is the way gravity wants a form to be, but you know, just naturally, then he assumed that inverting this and making it a structural element was the strongest form.
Makes sense.
Makes sense to me.
Yep.
But it's a beautiful shape. You know, it's a very beautiful shape, and it's the egg shape that we're going for. So I don't know how to make this egg shape. What he did is he's got these incredible scale models that he did for these buildings, and he either did them with chains or sandbags, or string with sandbags all on them to make these parabolas. So I don't know how to draw this, but a parabola, to express it in terms of math and in terms of visual geometry, a parabola is a section of a cone, equally sided isosceles triangle. And you spin that, you turn that, or you turn that into a three-dimensional form, which is, you know, basically a circle at the bottom and a single point at the top, as long as it's a 90-degree angle and perpendicular to the ground. You've got a cone shape. And a parabola is, so you imagine this cone coming up from here. A parabola is, you take a section of the cone. You just slice a piece of the cone, and then, as you might imagine, you have a parabola. But I don't know how to draw this. So we're going to do a drawing of a parabola on the ground. And actually, we're going to do a drawing of an ellipse. I knew how to make an ellipse mechanically. So give me a second.